Investigate horizontal transformations. Now in this example, I've taken up reciprocal function and I'll teach you how to sketch a good graph for a reciprocal function. And I will also tell you what mistakes you could do while sketching a reciprocal function. Right? So keep this in mind, and then we will see if you don't really take care of these things, how can you mess it up. So these are the two things which we are going to study here and then see what really happens. So the first step, so I'll write down here steps which we are going to do one by one, and then we will really sketch a good graph this time. Now, first step is when you look at the function. Now here we have two functions. One is f of x equals to 1 over x plus 1, and the other one is g of x equals to 1 over 1 minus x. They're kind of similar, but they are like, reflection in one, not in the other. Now what are we supposed to do here? We are supposed to describe the transformation and sketch the graph of each transformed function. So I'll do one of them for you, and I'll pick up this one, right? So this is kind of unique in a way that what is the coefficient of x here? Coefficient of x is not 1, it is minus 1. So whenever you have a function, then if the coefficient of x is not 1, you need to factor this, even minus 1. So let's factor this, and then we will write down a transformation. So it is 1 over, when we factor this minus out, we get x minus 1. Do you see that? It makes huge difference. We knew that there is a reflection on y-axis, but we didn't realize that this one is actually negative, and it will help us move towards the right side and not left, right? So minus 1 is movement towards the right and not left, right? So first point which we notice is factor coefficient of x, right? Now these are the points which you can't find in a book. It only comes from experience. So make a good note of these points, keep them in mind. Now, second is, it's a good time to describe the transformation once we have it in factored form, right? So the transformation is, let's answer this question now. So we write part A is reflection on y-axis, right? And second one is translate 1 unit right. So we have answered the question also. Well, so this part is answering question part A, let us say, right? Then we will do part B. Now we need to sketch the graph of each transfer function, and at present I am doing B and leaving A for you. Now when you want to sketch graph of reciprocal function, reciprocal functions have unique things, and two unique things are vertical and horizontal asymptotes. So first thing you have to figure out is where is the vertical asymptote. So we figure out where is vertical asymptote. Vertical asymptote means a point which is really not in the domain of the function. So, and that happens when denominator is 0. So to find vertical asymptote, equate denominator to 0. Our denominator is x minus 1 equated to 0. And when you do that, what do you get? You get x equals to 1. So we have a vertical asymptote at x equals to 1. So we know that. As soon as you get your vertical asymptote, x equals to 1, vertical means it's a straight vertical line at x equals to 1. This is what it means. So you have to plot this. But before getting into that hurry of plotting, I want to remind you of one more step. And that is, I should say, steps like this, factor coefficient, right? So let me go in this order. Steps like this, second step will be select scale. So that is a kind of instruction which I'm trying to give you. Select scale. Since 1 over x, if you put 2, it will be half, 4, 1 over 4. You are going to get a lot of fractions. Now if you have a scale, this unit as 1, you cannot draw all those fractions, right? So our scale should be at least 2 units as 1. So mark that scale. Remember, this is the most useful tip. So you get plus 1 here, that is what, and we get minus 1 here. So you get plus 1 here and minus 1 here. So that is your scale, this is your x-axis, and that is your y-axis. So make a scale with at least 2 units for 1, right? I don't mind if you put 4. At times, if you have some factor here which can reduce, I mean, where you're expecting like 1 over 10 type of values, the scale could be like much bigger, right? Now we are expecting kind of half and 1/4, so this is a good enough scale. Now once you have the scale, then rush for your vertical asymptote, not before that. So vertical asymptote is at x equals to 1. So draw a vertical line here at x equals to 1. So that is my vertical asymptote. Always use a scale to draw your graph, right? I'm kind of giving you a rough sketch here. Vertical asymptote. Now we'll go for horizontal asymptote. So horizontal asymptote is where? Horizontal line. Horizontal asymptote really means that if x approaches positive infinity, what happens to y? If x approaches negative infinity, what happens to y? Now positive infinity and negative infinity are not real numbers and we cannot plug it in the calculator. But when you are seeing a question like this, we are talking about numbers like 1, 2 and all. If you plug in 1000, 1000 is like infinity for 1. In this scale of 1, if I have to plot 1000, where will it be? Probably a mile away, right? So 1000 is a good number to try. So plug in 1000 in your calculator and see what do you get. So when you do, let's not try it out. If I write 1000 here, then 1000 minus anything will be a positive number, but this negative makes it negative. So when I am approaching this, then my y value will be approaching 0, but it will be kind of negative 0. Do you understand that part? Or you can even see from this equation. If I write plus 1000, I am going to get a negative answer in the calculator, right? Since it is 1 minus 1000, right? So it is negative. So we know now that we are, as we approach x positive infinity towards extreme right, then we are approaching 0, of course, but from the negative direction. That means we are approaching from this side. So mark that arrow. So mark arrow. Now, if you put minus 1000, minus will make this plus, and so your y is approaching 0, but from positive side. So this is very, very important, right? So you are approaching from this side. Mark these arrows. These arrows indicate that we have a horizontal asymptote, and let me draw a dotted line along the horizontal asymptote, which is along the x-axis, which is y equals to 0. But that is how my graph will be approaching, and will never reach there, but will be approaching x-axis. So this is kind of most important point for us, right? So that gives us a very good idea. Similarly, we have to see how are we approaching vertical asymptote. That means close to 1. Now, if I have a value here, which is like more than 1. If it is more than 1, then 1 minus, let us say 1.1 will be a negative number, right? Will be a negative number. So I am approaching infinity, but towards negative. So we have this arrow here. Similarly, if I have number which is less than 1, let's say 0.9. So 1 minus 0.9 will be positive. So we are approaching positive infinity. So now you know the shape of the graph is like this. At this moment, you can definitely sketch your graph, right? When it is sketch a graph, it is a very good time to sketch the graph. We just need a couple of more points to go. I'll recommend at least 3 points to go. So the first point is, where is the vertical asymptote? Vertical asymptote is at 1. So it is a good idea to write, now I'll make a table like this, in a horizontal way, so that we can just write down these points here and then calculate and then plug them in. Well, I'll recommend 5 points for you, but as far as I am concerned, I will do with 3 points. So we are trying to get some y values for some x values, right? And we know one thing, that we have a vertical asymptote here. Let's say this is my vertical asymptote, and this vertical asymptote is at x equals to 1. So this is at x equals to 1. So I have to take points on either side of vertical asymptote. This is what I'm trying to think like this. So this is 1, so I'll take the points in 0.5 increments. In 0.5 increments, right? So that point will be 1.5, and then I have to do 2, and then 2.5, so that is how we are good in 0.5 increments. And on the left side, less 0.5 will be 0.5 and then 0, right? But you should take like this more points than what I have taken. At least go to 2 more points, okay? Now, plug in these values and calculate. Now, if you find that to be more complicated, you can plug these values in the original function and get your points, right? It is a good idea to use original function at this point. Why? If you've done a mistake here, you will at least know that the mistake has been committed. So plug in 0 here. If I plug in 0, I get just the number 1 for y. If I plug in 0.5 and use your calculator, because these are decimals and you can do a lot of mistakes when dealing with decimals, right? So I'll recommend use a calculator. So, well, I will do some approximations. This is like half. 0.5 is half, right? So 1 minus half will be half, and when I do reciprocal of that, I should get 2, right? Now this is 1.5, 1 and a half. So 1 minus 1 and a half, this will give me a negative number because this is like 1 minus 1 and a half. So I get negative half, that means negative 2, right? If I put 2 here, then 1 minus 2 is minus 1, so I get minus 1 here. So like that, you have some points here. Once you have those points, then plot them on your graph. So we'll still move one by one. So at 1, you have 0. So at x equals to 0, you have 1. So at x equals to 0, you have 1. So this is your point, first point. At 0.5, it is 2. So this is 1. So at 0.5, which is here, you have 2. And that at 1.5, you have minus 2. So all of a sudden, at 1.5, you have 1, and this is minus 2. And at 2, you have minus 1. So at 2, you have minus 1. So there you are. And similarly, at 2.5, you will find yourself at, so this is 2, this is 2.5, you'll find yourself here, right? So it's kind of symmetrical. So you can just put 2.5 here. So if I write 2.5, then I get, which is minus 1 minus 2.5, you get minus 1.5, right? So minus 1.5 is 3 over 2, so you get 2 over 3. So you get some point closer to what the you get those points. Now once you get these points, then join them. But the important point here is, these fractions, at least you have good idea, you can actually show them. Do you see that? How and where they will fall. Do you understand? Then just join these points and draw your graph. Kind of like this. Yes, my suggestion is like that. Draw a neat graph showing, connecting these points. So that is your graph for the given function. Do you see that, right? Of course, I'm missing many points here, but that, make a table, use calculator, calculate those points, plot them. Now the important thing here is, since we have kind of expanded scale, I can take care of points like 1.5, half, 3.5, like those, right? So that helps, that helps. So this is how you have to draw any graph for reciprocal function. Minimum scale which you need to select is 2 units as 1. In my next video, I will show you that if you don't do this, then you can really mess up and you can't really plot a good graph, right? At times, if you have some factors like 2 or something here, where you are expecting much lower values, I mean like 1/4, 1/8, then you should use 4 as 1 and then plot, because this part of the graph is very critical and accuracy is required here. The rest of the part is like approaching some axis, right, which is not that critical, but you have to show at least 5 points here. Remember that I could only show 2 with my calculations. You need to show 5 points here, and these are the 2 important things: how the graph is approaching your asymptotes, and then you have to then you say that my graph is complete. Otherwise, it remains incomplete. Okay? I hope you appreciate these ideas. Thanks and all the best.